Hi everybody, welcome back to the kitchen. Today we're going to talk a little bit about relative humidity. And I picked kind of a stormy day, so hopefully our data will work out to show that. So when we were talking about phase changes of water, we were saying that when water evaporates and when it condenses, it releases or takes away a lot of heat energy. You're familiar with that because in the summertime and in warm weather, the human body is designed to sweat. And the express purpose of sweating is that when the sweat evaporates, it cools your skin. We can measure it with a fairly simple device. It's really high tech, actually. It's called a sling psychrometer. So what I have are two thermometers on a tiny little stick, and they swing. All right, the difference is one thermometer is plain, and the other one has a little cotton sock on it. And what I'm going to do is I'm going to wet the cotton sock. We're going to swing the sling psychrometer, and we'll measure the actual evaporation, because if evaporation causes cooling, we should have different temperatures on our thermometers based on evaporation from wind. So here's my little cotton sock. I'm going to go ahead and make it wet. So right now, to start, both thermometers are reading 22 degrees Celsius, which is pretty much standard room temperature. If you remember, 20 degrees Celsius is about 68 Fahrenheit. So just a little technical. Wetting my psychrometer. There we go. Alrighty, so we have 22 and 22. I'll say, let me set timer for cooperate watch. I'll set the timer for about 45 seconds to swing it. Here we go. This is for the lab. You know, keep in mind the weathermen and women have actual devices that are designed to measure this. All right, 45 seconds. Here we go. So my dry bulb temperature says 20. My wet bulb temperature says, let's see, 10, 12, 14, 16 Celsius. So pencil. Dry bulb temperature, 20 degrees Celsius. Wet bulb temperature, 16 degrees Celsius. All right, it's colder outside. I'm going to re-wet my little sock. And we're going to go outside, and it's currently snowing a little bit. So in theory, when you have precipitation going on, relative humidity should be almost 100%, because now the clouds are full and they can't hold any moisture anymore, and moisture starts to fall out of the sky. It's definitely true with rain. With snow, surface temperature matters as well. All right, here we are outside. So what we're going to do is try to measure the relative humidity. It's fairly cold out today. Outside, while it is snowing. So same procedure. I'm going to spin this lynx micrometer for 45 seconds and see what happens. Guess I should smile for the camera here in the driveway. Both of them. All right. 2, 3. All right. So let's see what we got. So we've got about 6 degrees here on the dry bulb, and oh, look at that. We have 6 degrees here on the wet bulb. Very nice. All right, back inside. We'll put our record here in the data table. We had 6 degrees for the dry bulb, 6 degrees for the wet bulb, and it is snowing out today. So from that, you use your chart to calculate the difference between the wet bulb and the dry bulb, and then to find the relative humidity. And we'll see what happens when you analyze that on your lab report. All right, thanks for joining us. Till next time.
Yo,